Hi, hello everyone and welcome to this video of the Exeter School on Urban Analytics in the Social Media Mining mini module. We will be talking about a brief introduction to text analysis. Let's assume that we gathered a collection of posts about cities that we might have mined from Twitter or from other social media. How can we investigate the language that is present in these messages? We will be trying to answer this question by reviewing some simple yet powerful analysis that we might do on text. I will be using as references mainly these two books, Twitter as Data and Natural Language Processing with Python. In particular, the second one is quite good because it's available for free online. Drop me a message if you would like to have the link. Well, in Python, there is a very powerful toolkit called the Natural Language Toolkit, or NLTK, that contains a set of functions that are quite powerful in terms of cleaning and extracting insights from textual data. I'm reporting here a table of the most frequent functions as reported in this book. When I talk about frequency, is really considering the most common functions that are used in analyzing text. Let's consider a specific example. Let's consider this line coming from a dialogue and given to the variable row. If we read it, this is just a sequence of words together with some punctuation. Ideally, we would like to access the individual words that compose this specific piece of text. So then we would need to split this text into a sequence of words and punctuation. These elements, words or punctuations, are called tokens in text analysis, and the command to pass from a certain sentence to its tokens in NLTK is word tokenize. So if we apply an NLTK word tokenize to row, then we will get a set of tokens. You will see, however, that some of these tokens are relative to words being into their plural forms, like ponds, for instance. So we might want to rather have them in their singular form, so that all cases of singular and plural forms can be just referred to as their singular baseline form. The way the process of transforming words into their baseline form is called lemmatization. The command NLTK WordNet Lemmatizer is able to transform individual tokens into their baseline form by checking for how different words relate with specific entries in a precompiled dictionary. The problem with this approach is that whenever there are words that are not present in the dictionary, lemmatization will fail. So this is often a very difficult procedure, and it's almost possibly never going to give 100% perfect results. Nonetheless, it will reduce the variability of word forms for our analysis, so it will be quite useful. For instance, you see that in the output here, ponds was now transformed into pond. So lemmatization is this process of normalizing text by reducing its variability. And once we have done this lemmatization, we might want to have a closer look at the words that we have. In fact, many of them have no actual meaning on their own, like for instance, for, a, of. These words are specifiers of meaning, so syntactically they are extremely important because they specify the meaning of nouns or adverbs or verbs themselves. However, on their own, these words are quite useless in the end. For instance, if we perform the frequency analysis on this text, we would find that articles like a or the would be quite frequent. This is because of the syntactic structure of language, not because of the specific content of text. So we might want to get rid of this information by deleting what we call stop words. Here is another example from another source that I encourage you to go and check. In this code, we are processing different tweets, and we are using the command nltk download stop words to download a list of stop words for the English language, which is then allocated to the variable stop words. And then, iteratively, we will delete in the tweets that we have the stop words that we don't want to have. Okay, so this can be useful for cleaning text and performing more sensible frequency analysis. In fact, frequency is the most basic analysis that we can do in a certain text. After we have tokenized, lemmatized, and cleaned the text, we might count how many times a certain lemma or concept occurred in a certain text. We can then visualize these frequency counts, frequency results, in two ways, either as ranks or word clouds. In ranks, we might rank concepts according to their frequency, so that the higher in the ranking, the more frequently a certain concept appear in text. In here, I'm reporting a ranking coming from an article about using Twitter data for understanding social perceptions of urban green spaces in urban analytics. And we will see that key concepts in this case were gentrification, housing, so the transformation of neighborhoods, and then also affordable houses, bike, weekend rise surroundings. So concepts related to affordability and quality of life. We could also visualize frequency results in terms of a word cloud. Since in Python it's a bit difficult to visualize word clouds in clear ways, I recommend for you to use an external service called wordart.com, which has a very simple graphic user interface where you can input specific words, place a tag that counts the frequency of these words, and then visualize the result as a word cloud where larger words will have a higher frequency in the original text. So you see that word clouds are visually immediate ways of visualizing the frequency of concepts in a certain text. There is a problem with frequency analysis because frequency considers words in isolation. It actually neglects their context. What we can do better? We can use bigrams of word co-occurrences to reconstruct how concepts appeared after each other in text. So mentioning an important paper in the field that used bigrams of word co-occurrences to perform text identification, let me give you this example. So we have this sentence. Again, this is based on the paper by Amancio, Akimushkin, and Oliveira. And we have this sentence. The idea is to apply the WordNet lemmatized function and the stop word removal in order to transition from the original sentence to a sequence of words where you see the lemmatizer normalized also adjectives like best and worst that are transformed into their base form, good and bad. We have this sequence of words that are ordered as they appear in text. Well, now we might transform this into a network by considering co-occurrences. Good co-occurred together with time, time co-occurred together with bad, and so on. So we might then draw these connections and create a co-occurrence network where nodes represent words and connections represent co-occurrences. literally words appearing next to each other sequentially in the filtered list of words from a certain text. Consider that we might do this analysis on a certain set of tweets. So for each tweet, we might perform lemmatization, stop word removal, and then we might build connections between consecutive words. We can do this iteratively on all the tweets, and this would lead us to a network representing how different words co-occur together or were syntactically related in text. So these networks are extremely powerful and also quite computationally easy to obtain for as a proxy for accessing the syntactic structure of syntactic dependencies in text between concepts. Let's have a look at an example in this paper about the visualization and analysis of mapping knowledge domain of urban vitality research. She, Miao, and C investigated different papers about urban vitality, and they built a co-occurrence network identifying specific concepts in the abstracts of these research papers. They found out that concepts tended to connect together with each other more tightly in different clusters, reflecting different semantic areas, like quality of life, like air pollution, like city growth and public space and greenery, and also urban design. So you see nicely how 437 documents were summarized and their knowledge was visually represented as a network of co-occurrence. These networks are extremely powerful for extracting insights from texts, from large volumes of text. There is also another way in which we might build co-occurrence networks. This is based on a paper of mine in collaboration with Valerio Restocchi and Simon Didin, where we built networks of hashtag co-occurrences on Twitter. Networks of hashtag co-occurrences have nodes that represent hashtags and links that indicate the co-occurrence of two hashtags in the same tweet. I encourage you to have a look at the papers of the material reported here, and thank you for the attention.